All right, so I think I'm recording. Let's take a look. We're looking at skill 8F, and we've been introduced to some trigonometric identities, the reciprocal identities, the quotient identities, and the Pythagorean identities. And these next set of 6 problems, the intent when you're in that section of identities is to try to use the identities to do these problems. But if you already are familiar with the definition of these trig ratios, and if you understand similar triangles, you might be able to do it in an easier way, because technically the directions don't say that I have to use these identities. So let me show you how I would do this if I didn't know that the intent of the author was to use trig identities. When I see the sine of pi over 6 is equals 1/2, the first thing that I would do would be to sketch a right triangle. And that's kind of a poor sketch. If I have an angle of pi over 6, I know that's 30 degrees, and I know this other angle is pi over 3, and I know from my 30, 60, 90 degree ratios and I know from SOHCAHTOA that sine is the length of the opposite leg over the hypotenuse. If I let this opposite leg be 1/2 and the hypotenuse be 1, then from the Pythagorean theorem, I can derive that this side is the square root of 3 over 2. I've memorized it because it's one of those special right triangles. If you don't believe that this is a square root of 3 over 2, take the square root of 1 squared minus 1/2 squared. And simplify this. So let's do that real quick. 1 squared. Let's write this as 1 minus 1/2 squared is 1/4, and 1 minus 1/4 is 3/4. And when you have a radical, you can take the square root of the numerator and denominator separately. The square root of 3, I can't reduce that, but the square root of 4 is 2, and that's how I have the square root of 3 over 2. But I never go through that derivation because I have memorized this, and it's one of those things that you're expected to know in taking the SAT and ACT. So at that junior level in high school, most students know this ratio. And now this 45, if I have a right triangle with 45 degrees, I know this is 45 degrees, and so I know that the sine is the opposite leg over the hypotenuse. If this is square root 2 over 2 and this is 1, because all of these 45, 45, 90 degree triangles are all similar to each other. And by the Pythagorean theorem, or by the fact that I know if these two angles are congruent, these two legs have to be congruent, I can illustrate that that side has to be square root 2 over 2 as well. So if I take these two triangles with me, I can now answer these 6 or 9 problems, whatever it is in this section, pretty quickly. So let's copy this. Let's come over here and paste my triangles. Let's get them out of the way over here. Now, the pi over 6 is not using the 45, 90 triangle, so I guess I didn't need to bring both of them along. So let's just get rid of that one just so we can have some room. So the cosine of pi over 6, cosine is the length of the adjacent side divided by the hypotenuse, and so that's the square root of 3 over 2 divided by 1, which is just square root 3 over 2. Alright, so now on this one, if I bring my triangle along with me, this time I'm using the 45, 45, 90, and so let's erase the other one, and let's recognize that 45 degrees is the same thing as pi over 4. So I know that 45 degrees is the same thing as pi over 4. So the cosine of pi over 4 is the same as the cosine of 45 degrees, and the cosine is the length of the adjacent side of the hypotenuse. So I'm just getting square root 2 over 2, and I'm done. Alright, so let's paste our triangle. which one are we going to use? Well, it says 45 degrees, so we'll use the one on the right. Let's get rid of this one on the left. And, this time it's in degree measure, not radian measure, so I can just look at it directly. Cotangent is the adjacent leg divided by the opposite leg, or the reciprocal of the tangent. Either way, these legs are congruent. So when you take the adjacent leg divided by the opposite leg, you get the number 1, because let's illustrate. You get square root 2 over 2 divided by, hey, if the numerator and denominator are the same number, that reduces to the number 1. Now for the tangent of 30, let's paste our triangles. And let's get rid of the triangle on the right. I don't need the 45, 45, 90 to answer this problem. I do want to recognize that 30 degrees is equivalent to pi over 6 radians. So I'm working with this angle. The tangent is the length of the opposite side divided by the adjacent side. So I know that the tangent of 30 degrees is equivalent to 1/2 divided by the square root of 3 over 2. You can see that the 2's are going to cancel, or if you can't see that, you've got 1/2 divided by the square root of 3 over 2, because this is a complex fraction, and you can rewrite that division as multiplication by the reciprocal. And now when you can cancel the 2 divided by 2 there. And so this product reduces to 1 over the square root of 3, and if I rationalize the denominator, then I get square root of 3 divided by 3 as my answer. Alright, so let's paste this. I can't select it. How come? Hey, let's do it that way. Alright, make it a little bit bigger. The pi over 3 is 60 degrees. I don't need this triangle. Pi over 3 is the same as 60 degrees. So I'm doing all of my ratios with respect to this angle. The sine of this angle, pi over 3, is the length of the opposite leg divided by the hypotenuse, so it's the square root of 3 over 2. And we've got one more, I believe. So I'm going to erase the triangle on the right because I don't need it for 45, 90. I know that 60 degrees is equivalent to pi over 3 radians, so I'm working with this. The tangent is the tangent of 60 is the length of the opposite leg. Opposite to this pi over 3 to the 60 degrees is the square root of 3 over 2 divided by 1/2. And if you can't see that the 2's cancel and this reduces the square root of 3, you can always do it in a few steps until you get kind of used to it, and you'll definitely see it after a little bit of practice. And the 2's cancel, and I get the square root of 3, and I'm done with that one. Alright. So hey, I'm going to do this in another video, and in fact I'm even going to come back and do all these again with identities, but this is the fast and dirty version of getting those answers. Talk to you later.